Hello everyone. In today's class, we will be doing question 8, 9, 10 and 11 of NCERT Class 11 Physics, Chapter 3, Motion in a Straight Line. So on to the first question, 3.8. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite directions with a speed of 54 km per hour each. At a certain distance, at a certain instant, when the distance AB is equal to AC, both being 1 km, B decides to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? So, for this question, we will first take speed of car A. Speed A, so we can take that as UA, that is equal to 36 km per hour. And to convert kilometer per hour to meter per second, we can do 36 into 5 by 18, which is equal to 10 meter per second. Then to find speed of B and speed of car B and car C, because they have the same speed, so speed of UB is equal to UC. So we can do UB is equal to UC is equal to 54 km per hour. We can write this 54 into 5 by 18, and that is equal to 15 meter per second. Now we have to find the relative velocity of car B with respect to A. So for relative velocity, we have U of B with respect to A, which is UB minus UA, which is equal to 15 minus 10, that is 5 meter per second. Now, speed of C with respect to A, which is UC minus UA, which is again 15 minus 10, that is 5 meter per second. Now, to find the distance traveled between car A and car B is 1 km that they give, and that is equal to 1000 meter. Now, time taken by car C to travel AC, that time is equal to distance by speed, but then we can take this speed in this question as relative velocity of C with respect to A, right? So UCA, that is 1000 divided by 25, and that I'm sorry, here in this part is wrong. Here we can take it as UCA is equal to UC minus UA is equal to 15 minus of minus, since it's in the opposite direction, so that is 25 meter per second. Here it's 1000 by 25, so then we can write that as 40 seconds. Now, to find the acceleration, since they're asking acceleration, we have to use S is equal to UT plus half AT square. So S is equal to UBAT plus 1 by 2 AT square, which is 1000, distance 1 km, is equal to 5 into 40 plus 1 by 2 into A into 40 square. So that is equal to 200 plus 800A, and 800A is equal to 800. So A is equal to 1 meter per second square. Therefore acceleration is 1. Now moving on to the next question. Two towns A and B are connected by a regular bus service, with the bus leaving in either direction every t minutes. A man cycling with speed of 20 km per hour in the direction A to B notices that a bus goes past him every 18 minutes in the direction of his motion, and every 6 minutes in the opposite direction. What is the period T of the bus service, and with what speed do the buses ply on the road? Okay, so we can, since there are two buses A and B, we can take one. They are connected by a regular bus service leaving every t minutes. So he notices that a bus goes past them every 18 minutes. We can take this, the velocity of bus, since there are, suppose, two buses. This is A and this is B. And this is the velocity of the person. So there are two conditions: either that the person, that the cyclist is moving along with the bus. This is case 1, and this is case 2, where the cyclist is moving against the direction of the bus. VC, this is VP, this is VC. So we can take it as the first case, same direction. So for that, we have to find the relative velocity of bus with respect to cyclist. So we can write that as bus with respect to cyclist. So VB minus VC, which is equal to VB minus 20, since they gave it kilometer per hour. Now, they told that the bus goes past the cyclist every 18 minutes. Therefore, distance traveled, we can write this as in this time interval. So that we can write as VB minus 20 into 18 by 60 kilometer. And since the bus leaves in either direction every t minutes, so distance traveled by bus is VB into t by 60, right? Now, from equation 1 and 2, this is equation 1, this is equation 2. From that we can write VB minus 20 into 8 by 18 by 60 is equal to VB into t by 60, which is equal to VB minus 20 is equal to VB into t divided by 18. So now in the opposite direction, before it was bus with respect to cyclist, now it's cyclist with respect to bus. So now since it is along in the opposite direction, we can write V of cyclist with respect to bus as VB plus 20, since in the opposite direction. Now bus goes past every 6 minutes if it's in the opposite direction. So we can write that as VB plus 20 into 6 by 60 kilometer, right? Since this is the time and this is per minute now, so this will become 10. Yeah, so this will become VB into 1 by 10. Sorry, VB plus 20 into 1 by 10. Just write that again. Kilometer. Yeah. Now distance traveled by bus in t minutes is VB into t by 60. And from equation 4 and 5, equation 4 is this, and this is equation 5. So from that we get VB plus 20 into 60 by 20 is equal to VB into time interval divided by 60, and that is VB plus 20 is equal to VB into t by 6. Now dividing equation 6 by equation 3, so that's VB plus 20 divided by VB minus 20 is equal to 18 by 6, that is 3, and VB plus 20 is equal to 3 VB minus 60. Solving this, 2 VB is equal to 80 and VB is equal to 40 km per hour. Okay, so we got these two values. We got the value of VB here, got the value of VB. Now, we can substitute the value of VB in the equations. So that's 40 plus 20 is equal to 40 into t divided by 6, and that's 60 into 6 is equal to 40 into t. Therefore t is equal to 360 divided by 40, which is 9 minutes. That is the final answer. Now moving on to question 10. A player throws a ball upwards with an initial speed of 29.4 meter per second. What is the direction of acceleration during the upward motion of the ball? That is the first question. So for the first question, the ball is moving under the effect of gravity. We know that. So since it is moving under the effect of gravity, therefore the acceleration is vertically downwards, right? Therefore the acceleration will be along gravity, the direction of gravity. That's it. That's the first answer. So we can write direction of A is equal to direction of B. Moving on to the second part of the question. What are the velocity and acceleration of the ball at the highest point of its motion? At the highest point, velocity will be 0 because there will be no movement. Suppose if a ball goes up and falls down, there will be a moment where the ball does not move. The object does not move. At this point, velocity is equal to 0. Therefore, the velocity will be 0 at this point. And since there is there is acceleration. Acceleration at this point is equal to the acceleration due to gravity, since it is moving at one point. So with respect to the earth, we can take that the acceleration is equal to 9.8, the same as g, meter per second square. Yeah. Now moving on to C. Choose the x is equal to 0 m and t is equal to 0 as to be the location and time of the ball at its highest point. Vertically downward direction to the positive direction of x-axis, and give the signs of position, velocity and acceleration of the ball during its upward and downward motion. So for this question, during upward motion, we can take upward. This is one part. So for this, position will be negative. Position is negative. For velocity, since it is working vertically downwards, that will also be negative. Velocity is negative, and acceleration will be positive. That's it. For downward, position will be positive. Position is positive. For velocity is positive again, and acceleration is positive. Now, moving on to D. To what height does the ball rise, and after how long does the ball return to the player's hand? So here they give G is equal to 9.8 meter per second square. So initial velocity is equal to 29.4 that they gave in the question, and G is equal to 9.8 meter per second square. Here is meter per second. Velocity at maximum height V is equal to 0 because it remains stationary at that height. So we know that V square is equal to U square plus 2AS, but since A will be taken as G, U square minus 2GH. Okay, so 0 is equal to 29.4 square minus 2 into 9.8 into H. So H is equal to 29.4 into 29.4 divided by 2 into 9.8. That is equal to 44.1 meter. Again, we are using the equation of motion. So for this, V is equal to U minus GT, and 0 is equal to 29.4 minus 9.8t. Since we are finding time is equal to 29.4 divided by 9.8, which is 3 seconds. So the ball will return to the player's hand after 3 seconds. Now, moving on to the fourth question, 3.11. Read each statement carefully and state with reasons and examples if it is true or false. A particle in one-dimensional motion with zero speed at an instant may have non-zero acceleration at that instant. Yes, this can be considered as true. If an object is thrown vertically upward, then at its highest point its speed will be 0. This will be 0. But its acceleration is equal to acceleration due to gravity. So A at any point, even if the velocity is 0, acceleration will be 9.8 meter per second square in the downward direction, of course. Now, on to the second one. With zero speed may have non-zero velocity. That is false, because velocity is defined as speed in a given direction. So because velocity is a vector quantity, speed is a scalar quantity, velocity is just speed with a direction. So if speed is 0, then magnitude of velocity is 0, and hence velocity will also be 0, since there is no point if it has any direction, even though there is no speed. So without speed there can be no velocity. So this is false. With constant speed must have constant acceleration. That is true. So a particle is moving with a constant speed, suppose, along a straight line. So if something is moving along a straight line, then its velocity is also constant, and hence its acceleration is 0. If velocity is constant, we know that acceleration is 0. So with constant speed must have constant acceleration. That is false. If the velocity is constant, then our acceleration of the object will be 0. Now D, with positive value of acceleration must have must be speeding up. False. Sorry. This is false. If we take vertically downward direction as positive, suppose, then ball thrown vertically upward will slow down in speed while acceleration is positive. Acceleration will always be positive since it is in the direction of g. That is only if the ball is up, it's thrown upwards. But if the ball is thrown downwards, it is true. The acceleration is positive and ball is speeding up. This has two cases actually. If case 1, it is moving against gravity, then the acceleration is negative, and if it's along the direction of gravity, then acceleration is positive. That is it. So it's false and true. That's it, guys, for this session. We did 4 questions this class, and I hope to see you in the next one.